Hi everyone, in today's video we are going to learn the application of reflection of a point in coordinate geometry. I have taken one question, let me read it out for you. Write down the coordinates of the image of the point 3, -2 when number 1 reflected in the x-axis, number 2 reflected in the y-axis, number 3 reflected in the x-axis followed by reflection in the y-axis, and number 4 reflected in the origin. So let's solve this one. Now I have drawn a Cartesian coordinate system and I have plotted the point P 3, -2. So we assume let the point be (3, -2 BP. Now number 1, reflected in the x-axis. Now when this point is reflected in the x-axis, so x-axis will behave like a mirror and the image will be formed on the opposite side of this x-axis. Here we can see that the x-coordinate will remain unchanged, but the y-coordinate will change its sign and will become positive. So number 1, reflection of the point P, which is 3, -2 in x-axis will be, suppose if we name this one as P prime, in x-axis is say P prime and its coordinate will be 3, 2. So that's the answer to number 1. Let's look at number 2. Reflected in the y-axis. So when this one is reflected in the y-axis behaves like the mirror. So the image will be formed on the opposite side of y-axis. So opposite side of y-axis means on this side, and the image will be formed somewhere out here. Let me draw this point here. Suppose this point is P double prime. Then what do we see? The y-coordinate remains unchanged, but the x-coordinate changes its sign. So it will become -3, -2. Therefore, reflection of the point P 3, -2 in y-axis is, suppose P double prime will be -3, -2. So that's the answer to question number 2. Now the third one. Third one is little tricky. What does it say? It says reflected in the x-axis followed by reflection in the y-axis. So when this is reflected in the x-axis, we get P prime. Now P prime is reflected in the y-axis. When this point gets reflected in the y-axis, then the image will be formed here, say suppose P3 prime. Now here what do we see? That the y-coordinate remains unchanged, but the sign of the x-coordinate changes. So reflection of the point P 3, -2 in the x-axis followed by reflection in the y-axis is the image P3 prime and its coordinate will be -3, 2. When this is reflected, the y-coordinate remains unchanged and the x-coordinate becomes -3. Now the fourth one, reflected in the origin. So when the point P, this is the point P, when it is reflected in the origin, then we imagine a mirror passing through the origin and making perpendicular with the line joining the point and the origin. So it will be reflected back here such that both the signs will change. So again, P3 prime is the image of the point P when it is reflected in the origin. So the image of the point, P, which is 3 comma minus 2, when reflected in the origin is P3 prime, which is minus 3 comma 2. Now let us look at another problem. Let me read out the question for you. Use graph paper for this question. Take 2 cm equals to 1 unit along both x and y axis. ABCD is a quadrilateral whose vertices are A 2, 2, B 2, minus 2, C 0, minus 1 and D 0, 1. Number 1. Reflect quadrilateral ABCD on the y-axis and name it as A prime B prime CD. Write down the coordinates of A prime and B prime. And number 3. Name 2 points which are invariant under the above reflection. And lastly, number 4. Name the polygon A dash B dash CD. We can read it as A dash B dash CD or A prime B prime CD. So since we have been told to use graph paper for this question, I have taken one graph sheet and I have drawn the x-axis and the y-axis, and I have taken the scale. In x-axis 2 cm is equals to 1 unit, and in y-axis also 2 cm equals to 1 unit. So if you can see from here to here, as I have marked here, this is 1 unit and the distance on the graph is actually 2 cm. So I have marked 1, 2, 3 on the right hand side, which is positive x-axis, and minus 1, minus 2, minus 3 on the left hand side, which is negative x-axis. Similarly, I have drawn 1, 2, 3 on positive y-axis and minus 1, minus 2, minus 3 in negative y-axis. Also, I have plotted the points, given points A, B, C, D also. A 2, 2, B 2, minus 2, C is 0, minus 1 and D is 0, 1. So let us proceed from here now. Now what is the first part? Reflect the quadrilateral ABCD on the y-axis and name it as A dash B dash CD. So we need to reflect the quadrilateral ABCD. If you look at this quadrilateral, I have tried to join this with broken lines to show you the original quadrilateral. So now when this is reflected in the y-axis, then y-axis behaves like the mirror and the image will be formed on the other side at similar distances. Now what is the rule when reflection takes place in the y-axis? The y-coordinate remains as it is, but the x-coordinate changes its sign. So A, when reflection takes place in the y-axis, will become minus 2, 2. So where is minus 2, 2? Minus 2, 2 will be at this point. So the image of A in reflection in y-axis will be A prime or A dash, and its point will be minus 2, 2. Similarly, when B is reflected, the x-coordinate will remain the same, y-coordinate will remain the same, the x-coordinate will change its sign. So it will become minus 2, minus 2, minus 2, and this point is your B prime or B dash, which is minus 2, minus 2. Now when C is reflected in the y-axis, the y-coordinate remains the same, the x-coordinate will change its sign, but since it lies in the y-axis, it will remain unchanged. That means this is an invariant point. Now we answer question number 2 and write down the coordinates of A dash and B dash. The coordinates of A dash is minus 2, 2. Similarly, the coordinates of B dash is minus 2, minus 2. So we have answered number 2. Now let's look at number 3. The question is, name 2 points which are invariant under the above reflection. So we saw that question number, point C and point D are invariant. So we will write the points C, which is 0, minus 1, and D, which is 0, minus 1, are invariant. When it is invariant? It is invariant when reflected in the y-axis. So we have answered number 3 also. The last one. Name the polygon A dash B dash C dash. We need to name this polygon A dash B dash C D. If you look at carefully, these two distances are same. And if you look at this figure, this is actually a trapezium. But these two distances are same. That means A dash D and B dash C are same. So we call it isosceles trapezium. Therefore, the polygon A dash B dash C D is an isosceles trapezium. Okay.